Hi everyone, in this lesson we're going to look at solving two-step equations, and I'm going to try to show you lots of different ways that this topic can be asked. Before we jump into solving two-step equations, let's just remind ourselves of how our order of operations work, and that's what you see on your screen right now. So you might know a mnemonic, something like BIDMAS or BODMAS, but either way we start by doing our brackets. Then we do our powers and our roots, we call these indices, then we move on to division and multiplication, and addition and subtraction. When we're calculating, we move our way down through these operations in order of priority. I'll show you a quick example so you can see what I mean. If we have this calculation here, we need to do our brackets first. So I'd do 4 add 5 to give me 9, and then I would need to multiply by 3 to give me an answer of 27. When we're solving equations, we actually reverse this order. We undo addition or subtraction first, then we undo our division or our multiplication, and then we undo our powers and roots. So let's say we wanted to solve the equation 3x add 5 is equal to 17. It helps us to understand how the equation 3x add 5 is equal to 17 has been formed. Well, my input is x, that's the number that goes into my equation. I've multiplied that by 3, and then I've added 5, and the result is 17. And if I wanted to find out what my input has been, I reverse the order in which I've done things, and I do the inverse. So I take my 17, I subtract 5 to give me 12, and then instead of multiplying by 3, I divide by 3 to give me 4. So hopefully you can see, not only have I done the inverse, so instead of adding 5, I've subtracted 5, and instead of multiplying by 3, I've divided by 3. I actually did it in the opposite order to what I did originally. X went in, it was multiplied by 3, then I added 5. Well, when I was going back through, I took away 5 first, and then I divided by 3. And when I reversed the operations and the order, it gave me an answer of 4. What that means is my original input was 4. Let's check it to see that it works. 4 goes in, it's multiplied by 3 to give me 12. I then add 5 to give me 17. So the answer to this equation is x is equal to 4. When solving equations, the function machine that we've seen previously is helpful, but we're going to move away from that quite quickly. So let's look at it without using our function machine. Here we have 3x add 5 is equal to 17. There are two things going on. I'm multiplying by 3 and I'm adding 5. And remember we said we want to work our way up back through it in the opposite order we would normally do. So I actually want to undo the addition by 5 first. So I'm going to subtract 5 from both sides like this. On the left hand side that'll leave me with 3x, and I'll do 17 subtract 5 to give me 12 on the right hand side. I'm doing 3 multiplied by x, so I want to undo multiplication by 3. So I'll divide both sides by 3. On the left hand side that gives me x, and on the right hand side I do 12 divided by 3 to give me an answer of 4. Pause the video, give this question a go, and I'll run through it in a second. Okay, so we've got 5x subtract 4 is equal to 26. I want to undo subtracting 4, so I will add 4 to both sides of my equation. I do it to both sides so that it's equal. On the left hand side that leaves me with 5x, on the right hand side that leaves me with 30. I'm doing 5 multiplied by x, so I want to undo multiplying by 5. So I'll divide both sides by 5. That leaves me with x on the left hand side, and 30 divided by 5 gives me 6. So x is 6. And what we can do is we can check our answer. We can substitute x back into my equation. So I would have 5 lots of 6 subtract 4, and that should be equal to 26. Well, 5 6s is 30, and then I'll be taking away 4, and 30 subtract 4 is 26. So if you get this situation where the left-hand side equals the right-hand side, you know that your answer is correct. Our next examples involve division and addition or subtraction. But let's look at this one. X divided by 2 subtract 6 is equal to 7. Let's work on that principle that I undo addition or subtraction first. So I'm going to undo the subtracting 6 by adding it to both sides. On the left-hand side, that leaves me with x over 2 is equal to 13. At this point, I'm doing x divided by 2. To undo division by 2, I'm going to multiply both sides by 2. On the left-hand side, that's going to leave me with x. On the right-hand side, that gives me 26. Now, this case is a little bit different. My fraction bar shows me that I'm dividing both x and 4 by 3. So in a sense, you could think of it like this. I'm doing x add 4, and I'm dividing both of them by 3. In this case, I want to undo the division by 3 first before I undo the addition by 4. I would show it like this. I would be multiplying both sides by 3 to undo this division by 3. On the left hand side, that's going to leave me with x add 4. And on the right hand side, it's going to leave me with 15. I can then subtract 4 from both sides. That's going to leave me with x on the left and 11 on the right hand side. So x is equal to 11. Pause the video and give these two a go, and then we'll have a look at them together. All right, so we're doing x divided by 5 add 3, and that's equal to 7. I'm going to subtract 3 from both sides. On the left, that'll leave me with x over 5, and on the right, that'll leave me with 4. I'm doing x divided by 5, so I want to undo dividing by 5. So I'll multiply both sides by 5. On the left, that leaves me with x. On the right, that leaves me with 4 multiplied by 5, which is 20. In this example, we need to multiply by 7 first because the fraction bar tells me that I'm dividing both x and negative 2. So I'll multiply both sides by 7. On the left, that leaves me with x, subtract 2. And on the right, that leaves me with 28. I then want to undo the subtracting 2. So I'll add 2 to both sides. And on the left, that leaves me with x. And on the right, that leaves me with 30. If you're enjoying the video so far, please subscribe to the channel and drop the video a like. It really helps us out. Thank you for doing that. If you're following along in our lesson booklets, you can now complete exercises 1 and 2. Or if you'd like to finish the video and do all of your exercises at the end, then that's absolutely fine. Our next examples involve some powers and roots. So here I have 2x squared is equal to 32. I've got two things going on. I'm multiplying by 2 and I'm squaring. And if I look at my order of operations, I want to undo multiplication before I undo squaring. So I'm doing 2 multiplied by x squared. I want to undo multiplying by 2. I'll divide both sides by 2 to start. On the left, that'll leave me with x squared. And on the right, I'll do 32 divided by 2. Well, 2 goes into 3 once with 1 left over. 2 goes into 12 6 times. So that leaves me with 16. Now in this case, x squared is equal to 16. And what that means is some number x multiplied by itself is equal to 16. And you might be able to spot that that number is 4. 4 multiplied by 4 is 16. But we have to be a little bit careful because actually negative 4 would also work, because negative 4 multiplied by negative 4 is also positive 16. Now the way I'd show that is I would square root both sides, and that would leave me with x on the left hand side. And I'd be doing the square root of 16, but I have to remember that I've got the positive and the negative answer. So it's plus or minus the square root of 16. The square root of 16 is 4, so it's positive or negative 4. Stacking your plus and minus symbol like this shows that you've got two answers, but you could also write them out separately. You could say x is equal to 4 and x is equal to negative 4. In my next example, I've got x cubed subtract 7 is equal to 20. Coming across to my order of operations and working my way back up, I want to undo my subtraction before I undo my cubing. The inverse of subtracting 7 is adding 7, so I'll do that to both sides. On the left, that'll leave me with x cubed, and on the right, 20 add 7 is 27. I'm doing x cubed, so I want to undo that. That means I'll take the cube root of both sides. So x is going to be equal to the cube root of 27. And when you're doing the cube root of a number, you want to think what number multiplied by itself 3 times gives me 27. Well, 3 multiplied by 3 is equal to 27. So x is equal to 3. This time we don't have the positive and negative answer because if I tried negative 3, well, negative 3 multiplied by negative 3 multiplied by negative 3 gives me negative 27. They don't give us the same answer, so we've only got one this time. Pause the video and give these two questions a go, and then we'll have a look at it together. So here we have x squared divided by 4 being equal to 25. I want to undo my division before I undo my squaring. The inverse of dividing by 4 is multiplying both sides by 4. On the left-hand side, that'll leave me with x squared. And on the right-hand side, 25 multiplied by 4, just one of those ones you need to know, it's 100. So I'm left with x squared is equal to 100. I then want to square root both sides to undo squaring. On the left-hand side, that will give me my answer for x. And I need to remember that when I take the square root of 100, I have two answers. So I'll use my plus and minus sign to show that I'll get the positive and negative result of the square root of 100. And the square root of 100 is 10, so I can have positive 10, and I can also have negative 10. In the second example, we have the cube root of x add 5 is equal to 7. I'll subtract 5 from both sides first. That's going to leave me with the cube root of x is equal to 2. Just be careful because the cube root of x is different to 3 multiplied by root x. They are not the same thing. I want to undo the cube root of x, so I will cube both sides of my equation. On the left, that'll leave me with x, and on the right, I'll be left with 2 cubed. And we know that 2 cubed is 2 multiplied by 2, which is 8. So that's your answer. Our next example is the square root of x divided by 3 is equal to 2. I've got division by 3, and I've got square rooting going on. I need to undo my division before I undo my square root. So I'll multiply both sides by 3 to start. On the left-hand side, that'll leave me with the square root of x is equal to, well, 2 multiplied by 3 is 6. I want to undo square rooting, so I will square both sides. That leaves me with x on the left-hand side and 6 squared on the right-hand side. 6 squared is equal to 36, so that's my answer. Pause the video and give this one a go. All right, let's run through it. Here we have 3 multiplied by the square root of x. This is not the same thing as the cube root of x. We're actually multiplying the square root of x by 3, so they're different things. Let's undo our multiplication first by dividing both sides by 3. On the left, that'll leave me with the square root of x, and on the right, 21 divided by 3 is 7. I then want to undo my square rooting, so I will square both sides. On the left-hand side, that'll leave me with x, and on the right-hand side, I have 7 squared. 7 squared is 7 multiplied by 7, which is 49. We'll now look at an example that has some brackets. So here we have 2 upon x add 3, and that's equal to 14. Now what you could do is you could expand your bracket. So do 2 multiplied by x, and then do 2 multiplied by 3 to give you 6. And you could then solve this two-step equation. But actually there's a quicker way to do it. What I can do is I can actually divide both sides by 2. Because I'm multiplying the entire bracket here by 2, I can undo that multiplication by 2 by dividing both sides by 2. On the left-hand side, well, I get rid of this in a sense, and it leaves me with x add 3. And on the right-hand side, that leaves me with 7. I can then subtract 3 from both sides, and that'll leave me with x is equal to 4. Here's one for you to give a go. Let's run through it. Start off by dividing both sides by 5. On the left-hand side, that leaves you with x subtract 1, and on the right-hand side, that leaves you with 4. You then want to add 1 to both sides. On the left-hand side, that gives you x. On the right-hand side, that gives you 5. If you're using our lesson booklets, you can now complete exercises 3 and 4, or you can finish watching the entire video and finish them all at the end. We're now going to look at some examples with negative coefficients. It's worth just quickly unpacking what the word coefficient means. It means the number that's in front of my x term. I'll start off by subtracting 4 from both sides. On the left-hand side, that's going to leave me with negative 3x. And on the right-hand side, I'm doing negative 11, subtract 4. While I'm getting more negative, this gives me an answer of negative 15. I then want to undo multiplying by negative 3. So I'll divide both sides by negative 3. That's the coefficient of x. On the left-hand side, that gives me x. On the right-hand side, I'm doing negative 15 divided by negative 3. A negative divided by a negative is a positive, so the answer to this is 5. In our next example, the x term has swapped positions. I'm doing 10 subtract 2x is equal to 14. And one thing you can do is you can add 2x to both sides. On the left, that would give you 10. On the right, that would give you 14, add 2x. And what you could then do is then solve this equation by subtracting 14 and then dividing by 2. But technically, that would have been 3 steps. This lesson is solving equations with 2 steps. So what we can do is something a bit different. Let me show you that. So instead of adding 2x to both sides to bring it over and make it positive, what I can do is I can actually subtract 10 from both sides. Now here's where I have to be careful. On my left-hand side, I'm left with negative 2x. On my right-hand side, I'm doing 14 subtract 10 to give me 4. And here I've got a negative coefficient of x, so I'll divide through by negative 2, both sides. On the left-hand side, that leaves me with x. And then I need to do 4 divided by negative 2. Well, it's a positive divided by a negative. That gives me a negative answer. X is negative 2. Try these two and then we'll run through them. Okay, so I've got negative 5x subtract 2 is equal to 18. Let's add 2 to both sides. On the left-hand side, I'm left with negative 5x. On the right-hand side, that gives me 20. I'll then divide both sides by negative 5. On the left-hand side, that gives me x. And on the right-hand side, 20 divided by negative 5 is negative 4. On the next one, I'll subtract 12 from both sides to start. That's going to leave me with, and I need to be careful, negative 3x on the left. 3 subtract 12 is going to be negative 9. So it leaves me with that. I then need to divide both sides by negative 3. That's the coefficient of x. On the left, that leaves me with x. And on the right, I'm doing a negative divided by a negative. So my answer is positive. My answer is 3. I'm showing you lots of different types of equations in this lesson. Our next examples have fractional and decimal coefficients. So here we see 2/3 of x subtract 5 is equal to 7. I will undo subtracting 5 first, so I'll add 5 to both sides. On the left, that leaves me with 2/3 x. And on the right-hand side, that gives me 12. I now want to undo multiplying by 2/3. So I would need to divide by 2/3 on both sides. And if you remember, dividing by a number is the same thing as multiplying by its reciprocal. So dividing by 2/3 is the same thing as multiplying by 3/2. And of course, I need to do that on both sides. If I did that on my left-hand side, I'd be left with x. And on my right-hand side, I need to do 12 multiplied by 3/2. 3/2 is the same thing as 3/2. And if I'm doing 12 multiplied by 3/2, well, then we might want to think, what's 1/2 of 12? Well, 1/2 of 12 is 6. So 3/2 of 12 is 3 times this. So it's 18. So my answer is x is equal to 18. Next example, I've got 0.5x add 1.2 is equal to 4.7. Let's start off by subtracting 1.2 from both sides. That's going to leave me with 0.5x on the left-hand side, and 4.7 subtract 1.2. I'll do that nice and quickly off to the side. 7 subtract 2 is 5, 4 subtract 1 is 3. So that gives me 3.5. I then want to divide by 0.5. And if you remember, 0.5 is a half. So that's the same thing as dividing by a half. And dividing by a half is the same thing as multiplying by the reciprocal of a half, which is 2. I actually need to multiply both sides by 2. On the left, that'll give me x. And I need to do 3.5 multiplied by 2 to give me 7. That's my answer. Pause the video and try these two. In your first example, you should have started off by subtracting 2 from both sides. That should have given you 3/4 of x is equal to 9. We then want to divide both sides by 3/4, which is the same thing as multiplying by 4/3. On the left, that will leave me with x. And then on the right, I have 9 multiplied by 4/3. Off to the side, I'll think, what is 1/3 of 9? Well, 1/3 of 9 is 3. So 4/3 of 9 is equal to 4 times 3, which is equal to 12. My answer is x is equal to 12. In the second example, I'm going to start by adding 2.2 to both sides. That's going to leave me with 0.1x is equal to 4.7. I then want to divide by 0.1. And remember, 0.1 as a fraction is 1/10. So I'm dividing by 1/10. Dividing by 1/10 is the same thing as multiplying by the reciprocal. So multiplying by 10/1, or just multiplying by 10. I need to do that on both sides. On the left-hand side, that leaves me with x. And on the right-hand side, that leaves me with 47. The last types we're going to look at quickly is where the positions have swapped. So sometimes this really throws people. So we've got 4 add 2x is equal to 22. We can still start by taking away 4 first from both sides. On the left-hand side, that leaves me with 2x. And on the right-hand side, that leaves me with 18. I'm then going to undo multiplying by 2 by dividing both sides by 2. On the left, that leaves me with x. On the right, that leaves me with 9. In this second example, the x term is on the right-hand side of my equation. And we treat this in the exact same way as if it was on the left-hand side. We'll undo subtracting 8 by adding 8 to both sides. 56 add 8 is 64, and that's equal to 4x. I then want to divide both sides by 4, like this. And 64 divided by 4 is 16. My answer is x is equal to 16. Now we can actually read this from right to left. X is equal to 16, or 16 is equal to x, but they're the same thing. Pause the video and give these two questions a go. Here we have -5 add 3x is equal to -26. Let's start off by undoing the -5, and we'll add 5 to both sides. On the left-hand side, that leaves me with 3x. Over here, I need to do -26 add 5. So I'm getting more positive. My answer is -21. I then want to divide both sides by 3. I'll do that really quickly. On the left-hand side, I've got x. On the right-hand side, 21 divided by 3 is 7. So -21 divided by 3 is -7. And the next example, we'll add 8 to both sides. On the left-hand side, that gives me 40. On the right-hand side, that gives me 4x. I'll then divide through by 4. On the left hand side, that gives me 10. And on the right hand side, that gives me x. So my answer is x is equal to 10. Okay, this is our last type of example. Here we have -1 is equal to 2, subtract x over 3. Let's start off by subtracting 2 from both sides. On my left hand side, that's going to leave me with -3. And on my right hand side, it's going to leave me with -x over 3. Now I want to do this in 2 steps. How am I going to undo the negative and the division by 3 at the same time? Well, let's think, what's the opposite of dividing by 3? Well, the answer is multiplying by 3. But if I want to get rid of the negative as well, I'm going to need to multiply by -3. That will turn the right hand side to positive because a negative multiplied by negative is positive. That means I need to also multiply the left hand side by -3. -3 multiplied by -3 is +9. And we've already spoken that we're going to undo the negative and the division by 3 by multiplying by -3. That leaves me with an answer of x is 9. Pause the video and give this question a go. So the equation says 0 is equal to 10 subtract x over 2. Now you might think, well, 10 subtract what is going to be 0? And the answer is, well, 10 subtract 10 is equal to 0. We could go straight to this. X over 2 is equal to 10. Then multiply both sides by 2, and that gives me an answer of x is equal to 20. The other way you might have done it is you might have subtracted 10 from both sides and got this. -10 is equal to -x over 2, and then multiplied by -2 on both sides. -10 multiplied by -2 is +20, and on the right hand side you'd have x, so x is equal to 20. If you're using our lesson booklet, you can now complete exercise 5. Thank you very much for watching the video.